Hello Year 10. This lesson today builds on last lesson where you learnt about the various processes in a river. It particularly focuses on erosion, the wearing away of the river itself. And if you could copy the title on the board, please. Have a little look through the two main objectives. You're going to need a pen, a pencil, and I think a good drink of water will keep your brains working. You've got 1 minute to do that. In this video, I'm not going to be pausing for a minute and letting you do it. I'm going to ask you to pause it. So when I ask you to pause the video, pause it. And when you unpause, we will carry on. So get the title copied, get the equipment you need. You have 1 minute. You pause the video now. Okay, well done. Hopefully that's all done. To begin with, a little do now, copy and complete the brain dump below. So I've given you the structure of it, a few words already written on there, which will guide you on those blue boxes. The 4 blue boxes are the processes themselves, and then you're giving examples as well. And you'll notice there's one in the bottom right, which is caused by something. You didn't really find out the causes of any of the other 3 last lesson, but there was one where you certainly did. That should take about 10 minutes. Sketch it out. You can pause the video now. Okay, there are the answers for you. Just spend 5 minutes or so looking through them all. You'll notice what I did say on the last slide is in the writing was that you hopefully have elaborated some of these words. So I've just gone for the obvious here, the basics, but you should hopefully be defining those words and writing as much as you know about them. So weathering, to remind you, is the breaking up of rock. If you imagine a large wall, it's too solid to be eroded yet. You couldn't physically remove any of the bricks yourself, but if you were to take a sledgehammer and to start to smash it, it would start to break up. That's similar to the act of weathering. That would then lead to you being able to erode it. In the case of rivers, the water now can erode the bank and the beds and other parts around the river of its valley through hydraulic action, the raw force of the water. To take it a slightly more technical definition, the water pushing into the cracks, pushing air and compressing it, forcing those cracks to widen and open and rock itself to, or the land, whatever it is made of, to disintegrate and fall apart and be taken away. Remember, that's the key difference between weathering and erosion. Weathering is breaking up, erosion is wearing away. It's the removal of the material itself. Abrasion then is where sediment is dragged in a river, usually along the bed, along the bottom of the river, and it scours, it wears away at the bed. Attrition is when the sediment itself, the load, you've come across that word before, last lesson, the load of the river is smashing against itself. So pebbles, stones, sand, whatever it may be, as they are carried in the water's flow, they smash into each other and they wear themselves away. And solution is finally the dissolving of certain rocks. Not all rocks can be dissolved, but some can. Limestone, for example, can be dissolved by water. So that is where you see potholing and cave systems underground. That's often solution erosion. You've then got transportation, which is then the movement of that sediment. Traction, I always like to think of it like tractor wheels. I used that diagram last lesson. Large boulders are rolled slowly, just like a large tractor wheel turns slowly. That happens on the bed of the river. Those rocks are too heavy for the river to pick up and move, even at its fastest, highest flow in some kind of storm event where there's been lots and lots of rain and the river is really flowing at a very high and fast level. Saltation next, it's when your pebbles start to bounce. So the river's got enough energy to pick them up, but not for long. So they return to the bed and they essentially bounce along. Suspension then is the smaller load in the river, the smaller sediment, the muds, the smaller grains of sand and things like that. And these are suspended. These are carried in the water. They are small and light enough and the water has enough energy to carry them. And finally, solution, which just like solution for erosion, this is the dissolved load. Any chemicals, materials that are dissolved into that water are also transported. And finally, deposition, which is caused by water losing energy as it slows down. What is it? Well, it's the dropping of that sediment. So hopefully you can see how all 4 of those processes are linked. Weathering leads to more risk of erosion. The material that is eroded is transported, and the transported material may if the water loses its energy, be deposited somewhere. If not, well, then it's carried all the way out to sea, and in year 11 you'll be doing coasts, and you'll see where some of that goes then. Okay, on to the next slide. So we're going to start with our first landform, which are interlocking spurs. Before we do interlocking spurs, though, there's going to be we've got to build to that point. We've got to think once again about the upper course of the river. So if you could copy that down for me, please. Interlocking spurs. Make sure you underline it. This is a subtitle. And spend 1 minute having a little think. What was the cross profile of the upper course like? You could draw a diagram if you like. You could write a few notes. You have 1 minute to think about that, and by all means jot a few things down. You can pause the video now. Okay, so here's your answer. Here's a photograph of the cross profile, yes, of the upper course of a river. So one thing you'll notice are the steep sides. It's a V-shaped valley. That's what we're going to be talking about in just a minute. Why is it a V-shaped valley? So get thinking there. Why is it like this? Spend 1 minute thinking about that. You can pause the video now. So here's your answer. Vertical erosion, eroding down. The river in the upper course predominantly, mostly erodes down into the ground, forming these steep-sided valleys. Remember the valley being the land either side of the river here. Where any water falls, it's going to flow down through gravity into the river itself. There we go. So why are the valley sides completely straight? By that I mean, why at the side of the rivers do they not go straight up as I'm illustrating on the screen now? Why does it not look like that? If that's the land and that's the land, why is there this V shape here? Have 1 minute thinking on that. You can pause the video now. Well, here's your answer. Weathering. So mentioned that back in the do now. Weathering is responsible for what's going on here. We'll find out more right now. So another subtitle for you to copy and 4 diagrams just to have a little look through. I will talk through them in just a second. So pause the video now, copy that title. Okay, so you should have that subtitle written. On the left, you can see the vertical erosion going on, and that almost sort of slightly unrealistic diagram. You don't ever see rivers flowing through deep, steep channels like that. Well, I say that, you can do, except the sides of that are likely to be rock, and you will find out why in just a minute. But in this circumstance, that is not realistically what's going to happen, because in the second diagram, you can see weathering going on. So in those 2 triangular zones either side of the river itself, that ground will be being broken up through various weathering processes. Now, you've covered freeze-thaw. If this is mountainous area, which remember the upper course can be, it could definitely be freeze-thaw. That's probably the more likely to be going on here. There are numerous other types of weathering that could be going on as well. So what happens then? Well, that ground is now broken up, remember. It's now no longer as solid as it used to be. It can be moved. We move to the third diagram, mass movement. Now, here's a key term you've not come across, something that comes up in the coast topic more, but we briefly mention it here. If you think about what the word mass means, in a math sense, it is, the what makes something up, its mass, and movement. Well, you know what that means. So this is about the material moving. It's as simple as that. It's a fancy word for a very, very simple process. The weathering occurs, that material then slides down, you'll notice, through gravity. Gravity is the main force here. It falls apart, it falls into the river, and the river itself then takes that material and transports it away. V-shaped valley is left. So that's how we go from vertical erosion through weathering, mass movement, to the formation of a V-shaped valley. And that is why those processes, or how those processes lead to this distinct shape of the upper course of a river. My task for you now, from memory first of all, draw each of the 4 stages of the formation of a V-shaped valley. So go back to the start of my explanation there in your head, and try and work through each of those diagrams from memory even. You will be doing some writing in just a minute, but for the moment, just keep it to the diagrams. You can pause the video now. You have 10 minutes at most you should need to do that in pencil. Pause the video now. So we start with the vertical erosion. You didn't need to write vertical erosion there, you're going to be doing that in a minute, but if you have, great, don't worry. We then move to the weathering, the breaking up of the valley sides. Then we have the mass movement because of gravity pushing that material down into the river itself to be washed away, leaving a V-shaped valley. So just check those for yourself now and make sure you have got them correct. If you haven't, you need to make corrections to them now because these are the notes for your book, so we need these to be perfect. Okay, so you've got the 4 diagrams finished, 4 sentences here, 4 bits of writing to show and describe what's going on and to give a brief bit of explanation. So match up the writing to the correct diagram. You can write it underneath. If you haven't left space for that, you can number the diagrams 1, 2, 3, 4 and number each of these 1, 2, 3, 4 underneath. The idea here, we're getting across the sequence of events. In physical geography, a key exam skill is writing in a correct order, in the correct sequence, and a full sequence, not missing anything out. This should take you 5 minutes to write these 4 sentences down at most. Pause the video now. Okay, so here's the answers, the 4 diagrams and the writing itself. Just give the diagrams a double check and have a look through the writing. Make sure it is correct. If you've made any errors, now's the time to correct them again, reminding you this will be useful revision material for your book. Try and work out why you got something in the wrong order as well. This is a logical order. You couldn't have any of this in a different order. You can't have mass movement before weathering because the material is not broken up. So have a little think through that. Make sure that you understand why it's in this order and why, if your order was wrong, it was wrong and what doesn't make sense about it. Okay, so we've established that V-shaped valleys are a common feature of the upper course of a river, and this really now is the actual key bit of learning, interestingly, despite the fact this is much more simple than the formation of V-shaped valleys, because AQA specification doesn't actually say V-shaped valleys, it says interlocking spurs. However, if we're going to understand interlocking spurs, hopefully you'll realize even from looking at the photograph here, V-shaped valleys are an important part of it. So what is an interlocking spur? Well, you can see them in front of you there. These are ridges of land. A spur is a ridge of land sticking out from the land around it. Why are these interlocking? Well, think of it like a zip. Each of these spurs sits one after the other, each facing different directions. And you can imagine, you can see it briefly in the distance, but you can imagine that in the distance the river itself is flowing down. If I draw on the screen for you here, you can sort of imagine, I think the river's probably flowing down here. You can't see it anymore flowing through the bottom, although you can probably see a little bit of it just down where I've labeled blue there. But the river itself, if I was to draw through this, is going to be going round and round each of these spurs, just like that. So that's what an interlocking spur is. How they formed? Well, here we go. Interlocking spurs are formed when the river erodes around sections of harder, more resistant rock in a V-shaped valley. It's as simple as that. There is no more complicated information than that. Your task now, you've got a simple little diagram there. It's a tricky diagram to draw. Try and get it correct. Try and show that each of those spurs are interlocking, and also the fact that the river is flowing through the bottom. The reason I've picked this diagram is it does show the river and the spurs, whereas some diagrams just show the spurs. You can't actually see where the river is. So do your best at this diagram. If you want to copy and paste it out of the PowerPoint that's also attached, feel free, and you can just print it if you can. Otherwise, quick sketch in pencil, please, as accurate as you can. Label those interlocking spurs and copy that sentence down. You've got 5 minutes. You can pause the video now. Okay, so that's our first landform, river landform in the upper course, caused by erosion are interlocking spurs. Now, waterfalls are next. So a title to copy and a little photograph just to have a look at there of High Force Waterfall on the River Tees. We're going to be coming back to that in a later lesson. One of the UK's most spectacular waterfalls. We certainly haven't got any waterfalls in this country on the same level as, say, Niagara Falls or Angel Falls or Victoria Falls, some of the more well-known around the world. But nevertheless, the UK's got some fairly spectacular waterfalls to visit. So yes, please copy that subtitle. It should take you about a minute. Pause the video now. Okay, so you've got a video to watch. Click on the link, it should work. Otherwise, type it in. A super retro video here for you. It is old school, but it does a very good job of explaining things. You'll see the presenter physically showing you the difference between harder and softer rocks, just like you've seen in a previous video, in fact. But the diagram of the formation of a video is incredibly clear and simple and very effective. So try and get over the low resolution and the dodgy presenter, but it is very informative. So give it a watch. Pause the video here. Okay, so you should have watched that video by now. Yes, look, you will need to use this information for the next task. What is that? Well, here it is. Once again, some diagrams. Physical geography has to be shown through diagrams, so you're probably already used to drawing lots of them, but you will get used to drawing more. So you've got 6 diagrams. They are not in the correct order. So based on the video, and you can by all means re-watch it, I need you to draw these diagrams in the correct order. You're going to number them 1 to 6, making it really clear the order of this sequence. And when you've done that, you're going to describe and explain what is happening below each diagram. Again, you can either do it below them, or you could, if you want, have each sentence numbered 1 to 6 to go with the diagrams. There's some key terms to use at the bottom. If you can, try and use all of them. Every single one of those is usable here. This is a slightly longer task. This will take probably 15 to 20 minutes, depending how quick you are at sketching. Don't worry too much about color in these diagrams. You can by all means add it when you're done, but it shouldn't need it if you've labeled it well enough. Okay, 20 minutes. Get drawing in pencil, get writing in pen, and I'll give you some answers in a minute. You can pause the video now. Okay, here's the answers. So please double check the order, first of all, double check the accuracy of the diagrams, and then double check that you have written something along the lines of what I've written. Obviously, I'm not expecting you to have written that word perfect, but if you think your writing is not up to scratch, if in hindsight now you look at it and think, oh, I didn't really write that, by all means, you can now copy mine out and use it. In purple are all the different key terms. So you'll notice I've used all of them, and a lot of them multiple times. You can pause the video now. Okay, a final slide for you, just to show high force in a slightly different light, and to put some of that learning you've just done into practice. You can clearly see here the gorge. Gorge is something that I don't know why, but a lot of students find kind of tricky to visualize. Just think cliff face, just cliffs down the side of the river made of hard rock, as you can see there. It's not much more to it than that. Usually there is a waterfall at one end of it, and certainly we are learning about them being formed through waterfalls, so there will be a waterfall at one end of them, with the river flowing through the rest. You can see on this diagram where I put the red dashed lines. If you look carefully, you can see the rock above it and the rock below it. Slightly different colors, slightly different layouts, the various cracks, the joints in the rock are slightly different. It doesn't look the same. It's clearly 2 types of rock, and it's exactly it. Harder rock at the top, softer rock at the bottom, just like the presenter said in the video. And you can even see an undercut there. You can see that darker area sort of undercutting. This waterfall is being formed exactly the way that the textbooks tell us waterfalls should be formed. You can even notice, if you look carefully, that the rock to the top, the harder rock, the more resistant rock, it's that white sort of mottled color to it. That's lichen. You can also see some sort of small vegetation growing out of it. What does that tell us? Well, that tells us that it's been there for a long time. If there are plants growing on it, if there's lichen growing on it, that means that it has not been eroded away for quite a while. Whereas look at the rock at the bottom, nothing. no lichen, no plants, no nothing. That rock is clearly being eroded much more rapidly, much more often, which means that lichens and things like that don't get a chance to grow on them. Well, that's it. So far, we've crammed quite a lot in there, so you've probably, hopefully, hit the hour mark about now. My wife's talking in the background, always helpful. Well, hopefully that all makes sense. There is another lesson following this, technically, by your timetable. There should be lunch now, so enjoy your lunch. You're then going to be learning about meanders and oxbow lakes on a river, and there will also be a quiz after this as well to do, where you'll get some questions on this. So hopefully that will make sense. If it doesn't, go back, have a little look through. The joy of this kind of learning is you can go back to it quite easily. Go and look up some things and find them out. Otherwise, have a lovely day. I shall speak to you in a little while. Thank you very much.